Okay, continuing on from our last video about finding factors of numbers. In this one, we'll find basically the prime factors of numbers and display a quick method of how to find them. But before we start, we need to understand what a prime number is. And basically, a prime number is any number that has only itself as a factor and 1, and basically no other number as a factor. So I'll just show you a quick example. If I have, say, let's say 5. Let's find the factors of 5. We know that 1 times 5 is 5. Let's move on. Does 2 divide into 5? No, we don't get a whole number. Does 3 divide into 5? No. What about 4? No, 4 doesn't divide into 5 to get a whole number. So and then eventually we come on to 5, and 5's already there. So the factors of 5 are just 1 and 5. That means that 5 is a prime number because it only has 1 and itself. So basically what prime factors are basically just factors of a number that are prime. Okay, let's have a go at finding some prime factors of numbers. I mean, just an important thing to note here is that numbers can be broken down into prime factors, basically as a product of prime factors, and it's sort of any sort of number. You can break them down into prime factors. So let's have a go at finding the prime factors of 12. I mean, the procedure is very simple. All you do is you write down the number you want to find the prime factors of, so 12. Let's do a little box around like that. And what we do is we start with the smallest prime number. I mean, I've got a list of the prime numbers here. They start off with 2, 3, 5, 7, 11, and they go on. So we always start off with the smallest prime number, and we see if it divides into the number. When we say divide, I mean you know, if we get a whole number. Okay, so there's 12. What happens if we say do 12 divided by 2? What do we 12 divided by 2 is 6. So we write down 6 there. We'll do another little box like that. Now the method is to keep going with the smallest prime number you've got. Does 2 divide into 6? Does 2 divide into 6 to get a whole number? Yeah, we get 3. Yeah, so we do another box. We write down 3. Now we continue on with the smallest prime number we've got. And does 3 divide into 2 to give us a whole number? No, it doesn't. So what we do is when our smallest prime number that we had doesn't divide exactly into what we've got here, what we do, we move on to the next prime number, the next largest prime number, which in this case is going to, after 2, is going to be 3. 3 is the next prime number after 2, and we see if that number divides into the number we have here. So let's see, does 3 divide into 3 to give us a whole number? Yes, it does. And what it does, we get 1. Now once we have the answer of 1, we basically stop. That's basically telling us that that's it, we found all the prime factors of 12. It's when we get 1. We just write down the prime factors of 12 as 2 times 2 times 3, which is equal to 12. 2 times 2 is 4, 4 times 3 is 12. So that's it. That's how we use. This is basically a very simple method of finding the prime factors of a number. But the thing to note is that you start off with the smallest prime number and then continue with that. If the result here divides exactly by it, but when it doesn't, you move on to the next one. We'll do some examples and hopefully you'll get this. Okay, let's have another example of finding prime factors. This time let's find the prime factors of 40. So basically what we do is we write down 40 here, draw a little box, and now we start off with the smallest prime number, which is 2. Does 40 divide into 2? Yes, we get a whole number. We get 40 divided by 2 is 20. So what we do is draw another box like that and write down 20. Does 20, so now we remember we're still with our smallest prime number, which is 2. So we check with 20. Does 20 divide into 2? Yes, it does. We get 10 as a whole number. So yeah, we write down 2 there because 2 goes into 2 divides in 20 divides into 2, and we write down 10. Draw another little box. Now, does 10 divide into 2 to get a whole number? Yes, it does. We get 5. So write down 2 again. 10 divided by 2 is 5. So write down 5. Draw another little box. Now, does 5 divide into 2? No, it doesn't. So what we do is we move on to the next prime number, which is 3. And we check. So we check with this number now. We check. Does it divide into 3? Does 5 divide into 3 to give us a whole number? No, it doesn't. So that means we move on to the next largest prime number, which is 5. Right. Does 5 divide into 5 to give us a whole number? Yes, it does. 5 divided by 5 is 1. So now once we get the answer of 1, that means we're finished. And so we can just basically write down the prime factors of 40 as, so just reading off our list here. So it's 2 times 2 times 2 times 5. So we can actually rewrite all the numbers that are the same being multiplied as powers. So we can write down 2 to the power of 1, 2, 3. 2 being multiplied by itself 3 times. So 2 to the power of 3 multiplied by 5. So yeah, this is how to find the prime factors of 40. So 2 times 2 is 4, 4 times 2 is 8, 5 times 8 is 40. Okay, let's do some more practice. Let's find the prime factors of 33. So we write down 33 here. And let's start with the smallest prime number, which is 2. Will 33 divide into 2 to give us a whole number? No, it won't. So what we do is we move on to the next highest prime number, which is 3. So we write down, Does 33 divide into 3? Yes, it does. We get 11. So we write down 3 here and 11 here. Draw another little box. Now in this example, what I want to show is that yes, yes, we would say after 3 we would go on to check 5. But if 11 doesn't divide into 5, so we would then check 7. But 11 doesn't divide into 7 either to give us a whole number. Then we would move on to 11. 11 divided by 11 will give us a whole number. The point of this example was to see that if our result here, after we've divided by a prime number, is a prime number, it's already a prime number. You don't have to you don't have to check sequentially after the next prime number and the next largest one. So it's a good idea to memorize some of these prime numbers. Here 11 is, we've got a prime number already, so we just jump to the prime number 11. We don't need to, after 3, we don't need to check 5, 7, because the number here is already a prime number, we go straight to 11 and just write down 11. 11 divided by 11 is 1. So and then we're finished. So the prime numbers, the prime factors of 33 is 3 times 11, which is equal to 33. Let's do one more quick example of finding prime factors, this time of 25. So again, we just write down 25 and draw a little box. So again, we start off with the smallest prime number, which is 2. Does 25 divide into 2 to give us a whole number? No, it doesn't. What about, so we move on to the next one, which is 3. Does 25 divide into 3 to give us a whole number? No, it doesn't. So we move on this time to the next highest prime number, which is 5. So does 25 divide into 5 to give us a whole number? Yes, it does. We get 5. So I write down 5 here and draw another little box. So 25 divided by 5 is 5, so I write down 5 here. Okay, so again, sticking with my current prime number, does 5 divide into 5 to give us a whole number? Yes. So 5 divided by 5 is 1. So we write down 1 there. So basically, when we get 1, that means we're finished. So the prime factors of 25 are 5. Just reading off the list here. 5 times 5. Again, we can write this as we can write this down as 5 squared. It's 5 times 5, yeah, is equal to 25. So yeah, this is the prime. In this example, I wanted to show that you move. Sometimes the very first prime number won't work, and neither will the next one, and you have to sort of move down sequentially along your prime numbers. So yeah, this is a very quick and easy method of finding prime factors. You just use this little box method, and move sequentially along the prime numbers, and you stop until you basically stop when you get 1. So it's just basically successive division until you conclude with the 1 here, and that's it.